Welcome to homework.
Okay, so our first Lewis structure is phosphorus, and we know hydrogen is always terminal, right? And so phosphorus would have to be the central atom. We also know that phosphorus um, is going to bring 5 electrons to the party. Hydrogen, each of these is going to bring 1 electron. So we'll get a total of 8 electrons. We've used 2, 4, 6, which means we'll have 2 left over to form a lone pair. So this would be the Lewis structure for pH3. Next, we've got H2S. You'll notice that S, sulfur, is isoelectronic with oxygen, right? It's very much like oxygen. So this is basically an analog of water, right? H2S is like H2O. In either case, sulfur brings 6 electrons to the party. Hydrogen, we've got 2 of them, so they'll bring 2. We'll have 8 total electrons to work with. Sulfur must be the central atom. Terminal, hydrogens are always terminal. Okay, so we've got 2, 4 electrons, 4 left, 2, 4, 6. And you'll see, right, just like water. Okay, next we've got HCl. Again, there's really only one option for bringing them together. Hydrogen brings 1 electron. Chlorine is in group 7, it brings 7. We've got 8 electrons total. We can only have a single bond and no lone pairs to hydrogen, so the remaining 6 electrons must be on chlorine. And this is the Lewis structure for HCl. Finally, we have, next we have C, carbon tetrachloride, right? We'll notice here that whenever we have halogens bonded to carbon, they are terminal, much like hydrogen. They're never bridging, and then okay, so in either case, these will essentially behave like hydrogens. You can think of it in terms of their electronegativity. These are more electronegative than carbon, or they're the most extreme in terms of electronegativity. So carbon should be central. Halogens always have a single bond to them. They are charged if they have more than one bond, right? So we know that it'll be a situation like this, and then we can look at electrons and say, well, carbon is going to bring 4 electrons to the party, while each of the chlorines will bring 7, so a total of 28 electrons for a total of 32 altogether. And in fact, since there are 4 of them with 2 in each bond, we can really add the remaining 6 to each. You can think of each chlorine with its lone pairs in the bond representing 8 electrons, and 8 times 4 is 32. So we know that to be the correct number of electrons. Finally, we have silicon with 4 hydrogens, or what is this? Silane. Okay, so silicon in the periodic table is directly below carbon. So much like carbon, it wants to have 4 bonds total to be neutral. Hydrogen wants to be terminal, so we really just expect something like 4 single bonds to hydrogen, no additional lone pairs required. And if we look at the electrons, we know silicon, like carbon, should bring 4 electrons, and the 4 hydrogens with 1 electron each should bring 4 electrons for a total of 8, which 2, 4, 6, 8 in bonds is all accounted for here. Next, draw a generic Lewis structure for a molecule formed between atoms group 1 and group 16 elements, right? So that is, group 1 would be something like lithium, or hydrogen, technically, although let's instead consider, we're going to have to use hydrogen, right? Because lithium, etc., sodium, these all form ionic compounds, not so much covalent compounds, right? And ionic compounds don't make very good Lewis structures. The Lewis structure for say a ionic compound would be something like lithium plus, right? And then O2 minus. That's not really a Lewis structure, right? So let's do H, which is from group 1, and then O, which is from group 16. Or better yet, let's do selenium, right? Okay, same idea. So selenium is isoelectronic with oxygen, and and sulfur being right between below them in the periodic table. So this is going to behave much like water. We'll have a central selenium and 2 bonds to hydrogen. Right. In terms of electrons, we'll have 6 from selenium and 1 from each of the hydrogens to make a total of 8, which means we'll need 2 lone pairs on selenium. So this is basically analogous to water.